Okay, our new topic in science is now going over density and convection. We already talked about radiation and conduction as types of heat transfer. Now we're going to go over convection as a type of heat transfer. And with convection, we also have to understand density in order to understand how convection is going to work. So, some of the things that we looked at in class were these density bottles, where we have different solutions layered on top of other solutions, mostly just different types of oils and waters, since oil and water have such a different density that they will not combine. So in this one over here on this side, we have water with blue lamp oil on top, and then we have water dyed blue with red lamp oil on top, and then we have a vegetable oil with dyed blue water on the bottom. And the lab that we're going to be looking at in class is right here, where we take a few drops of colored solution, which is essentially salt water, and we're going to try to layer the different colored waters based on their salinity, or the amount of salt they have. So as we're going through that, we're looking for the correct answer of blue, yellow, green, and red. And we have the lab where we're going to take the blue water, which is the densest water. We also weighed the different waters, and we've seen that when we weighed the same volumes of these waters, that the blue was also the heaviest. Next, we mixed in the yellow, and if we do it carefully enough, we can get the yellow to layer on top of the blue without mixing together. And then we take the green, and we can get the green to layer then on top of the yellow. And finally, the red. The red is actually just plain water. There was no salt added. It was just plain water dyed red. So we started off with the blue, which was the highest amount of salt and the densest, and then we had the yellow at the next saltiest, or second salinity, and then we had the green, and finally the red was just plain water. We then measured out 25 milliliters in a graduated cylinder of each solution, subtracted the amount for the empty graduated cylinder, and we came out with just the masses of the solutions themselves. So these might vary a little bit from what we actually wrote down in class, but they're going to be very, very close. I believe in class we had 26.1 grams, and then in the yellow we had, I think, exactly the same actually, 28.2 grams, and then the blue we only had 29.1 grams when we measured those out. Okay, and it gets down here to the question, what do you think caused the salt solutions to layer this way? The amount of salt dissolved in a measure of water determines the density of the solution. The solution that are a lot saltier or heavier solutions will go to the bottom, and then the ones with less salt will float on the top. They're not as heavy. We also took a look at then calculating the density of those solutions. So mathematically, we went through and we divided the mass of the solutions by the volume of the solutions. And we see here, like, 25 divided by 25 would give us a density of 1 gram per milliliter. As we go through and work these out mathematically, again, mass divided by volume gives us the densities of the different solutions. And the answers here, like I said, again, may vary because we had slightly different masses in class. Okay, from that we went on to a separate problem here, where they give us an example of this purple solution that was mixed together, and the purple solution had a volume of 35 milliliters and a mass of 41 grams. When we calculated the density of that, we got 1.17 grams per milliliter, and because we got a different density in class, I believe we only got 1.17 grams per milliliter for the blue solution, it would go to the bottom. In this example, the purple solution would go between the yellow and blue because we get a different density than we did in class. We also looked at the worksheet here, again doing some more practice problems with solving for the density. We have Rico making a shaking toy, almost like a snow globe, for his sister. He mixed up a salt solution, 500 cc's or 500 milliliters of salt solution. He weighed it and found it had a mass of 585 grams. When we divide the mass 585 by the volume 500 milliliters, we get a density of 1.17 grams per cubic centimeter or milliliter. And we find out that the solution will work for his sister's toy because the density of the stars is less than the salt solution, and the leaves have a greater density than the salt solution, so the leaves will sink and the stars will float. Next, we read the article Density in Class. So it was talking about the density of different objects. It started off talking about some balloons, and if we fill them with different objects, some will float down slowly, and some will actually rise up, depending on what they have in them. As we go to the different articles. Okay, they kind of start going over the demonstration that we did in class, and they start weighing out the different solutions. It talks about the density of liquids, and they are weighing them out. And it continues explaining the volumes of the solutions and the mass of the solutions, and then it goes into how to calculate for the density of those solutions. Kind of a recap of exactly what we went over in class. Then it starts to go over the different things about density and how we have cubic centimeters, which is equal to a milliliter. And we talked about that in class, where we had 1,000 cubic centimeters and we had 1,000 milliliters, and we filled both containers up with water, and they both had the same amount of water. And the article kind of goes over that again as a recap, how there's no difference between a centimeter cubed and a milliliter. And the article finishes off talking about air, okay, and the density in air, and then it starts talking about density and weather. And it gets into some different questions. We have the answers to those questions. What do you think the density of a person might be? And it goes on to explain that the density of a person is going to be very, very close to that of water with 1 gram per milliliter. Depending on whether you're holding your breath or not, like it uses the example here of floating or sinking in water. And then it has the second question here asking about hot air balloons, and that's where we're going to start to talk about air transferring heat through convection, where hot air is less dense and than cold air, and when the balloon system is less dense than the surrounding air, it's going to rise, and then when the balloon system comes back down to Earth, we're going to cool off that air or not add any more heat to that air and allow it to then become denser and heavier, and it will then sink in comparison to the surrounding ground. If you have any questions about anything I went over in this video or anything we went over in class, feel free to stop by and ask.